in this lesson, you guys are going to get introduced to logarithms. Now, logarithms are used to solve for exponents. That's essentially what they're created for. So you guys may have had equations in the past where you've had an equation with an exponent in it, but you've probably never had an equation where the variable that you were trying to solve for was the exponent. So that's what logarithms help you guys do. So when it says find the inverse of an exponential function, right in that equation, y equals b to the x, x is the exponent. So we rewrite this, that b comes over and becomes a log base b, y is still there, equals x. So if you can solve for this, you'll be able to get the value for x. So logarithms are just a way to solve for x, and that's what that's saying down below here. We know how to solve for y if we have values on that right-hand side. So if we move down to this box, it says the log of x with a base b, so that b is like a subscript, it's tiny, is written as log base b of x equals y. So if we go back and forth between log, exponential, exponential to log, this is how you guys are going to rewrite the expressions. So logarithm base 10 of x is written as log x. So when you guys don't see a base there, that's really log base 10 of x. It's just that that's what we have to know because those are the place values we work with. We work in bases of tens, hundreds, thousands, 10,000s. So just like when you guys know that 3 really equals 3 to the first, and the square root of x has an index of 2, when you don't see a base or a subscript there, you have to know, okay, that's a base 10. The other logarithm you need to know is the natural log. So a logarithm with base e of x is written as the natural log of x. So logarithm base e, ln of x, and if you don't see a subscript or a base, no, it's a base 10. So let's actually go and try to solve for some of these. It first says write the following in exponential form and solve if possible. So if you're paying attention to that formula up in the box, to go from log to exponential, that base of the log is going to get moved over and become the base for your exponents. So if we rewrote this, the log gets canceled, removed, goes away, and this becomes 3 to the second power equals 9. Is that true? Is 3 squared 9? Yes. So the base of the log came over, became a base, but it's now a base for an exponent. So number 2, x gets moved over. So x to the third power equals 8. What would x be? What cubed equals 8? 2. Number 3, log base 4 of 64 equals x. The 4 comes over. 4 to what power equals 64? 4 cubed. You just solved for an exponent. So I don't care if you guys write the whole expression or you just tell me what the expression is equal to. All I'm checking for is that you understand what's going on in the problem. So let's go down, and this where it says to find the exact value. So I'm going to do a couple, and you guys are going to do a couple. So log of 100. Again, this is really log base 10 of 100. So 10 to what power equals 100? 2. Number 7, log base 4 of 4 to the 6th power. whenever you guys have a base of a log and the base of an exponent in the same problem that are equal or the same, they're going to cancel out. And the reason that is because if you rewrote this, 4 to what power equals 4 to the 6th. Well, if we're looking for the value and they both have the same base, this has to be 6 to make them equivalent. So what happens is they cancel out and you're just left with that exponent. So number 9, again, your natural log and your e cancel out and you're left with 601. Anytime you guys see a natural log or e in the same problem, they're inverses. So anytime that happens, you guys can cancel them out. They undo each other. Excuse me. And I'll do 10 and 11 with you guys, and you guys can try 4, 6, and 8. So number 10, okay, 8 to what power equals 2? Okay, well, we're not going from a smaller value or a whole value to a fraction or vice versa, a fraction to a whole number. So how do we get from 8 to 2? We can do it, but what would we have to do? Would we square it? That would get us to 64. We can't take the square root of it to get to 2 because it's not a perfect square. We can take the cubed root of 8 would equal 2. Well, logarithms have to do with exponents, not radicals. So based off your knowledge of rewriting radicals, we could rewrite 8, or the cubed root of 8, as 8 to the 1/3 equals 2. So what does that exponent have to be? 1/3. The cubed root of 8 would give you 2. Because we're going to a smaller value. The other ones, you were going to a larger value. 3 squared equals 9, so your exponent had to be larger than 1. So, logically, okay, if we're going to a smaller number, then our exponent has to be smaller than 1, a fraction. So let's look at number 11. Log base 7 of the cubed root of 7. Again, rewrite this in exponential form because logarithms don't really deal with radicals. And radicals aren't going to help you in this situation. So if we rewrite this as log base 7 of 7 to the 1/3, now the base of our exponent and the base of our log are equal. And if we rewrote this, they would cancel out. So this is going to equal 1/3. So go ahead and try 4, 6, and 8. And see how you guys do. Let me know if you need any help.